Okay, so here is solids in contact 1. This is a problem that you can find on the T4 website if you look up T4.8. I'm just going to give you a second to read the question and then I'll get started. Okay, so a photograph of 3 balls is shown. All 3 are in mutual contact and rest on the horizontal plane. As we can see 2 of them at the minute that are sitting on the horizontal plane here as our XY. The centers of the 2 larger spheres or ones lie in a line which is parallel to the vertical plane. So when I look down in plan, the 2 center points are going to be parallel to the XY line here, or the vertical plane, because when we look down, the XY line symbolizes the vertical plane in plan, and when we look in elevation, the XY line symbolizes the horizontal plane in elevation. The drawing below shows the elevation of the 2 larger spheres which are touching or in contact with each other. Project a plan of the 2 spheres showing clearly how the projections of the point of contact between them is determined. So that's our first step. So we need to draw the 2 of these in plan. So first things first, we're going to project down the center points of both spheres and find where they lie in plan. So I'm going to come down perpendicular to our XY line. Same with point B, or the center point of B. And what I'm going to do is I'm going to leave a 10mm gap between the XY line and our largest sphere. So I'm going to move our largest sphere out 10mm from the vertical plane. I'm then going to find a point on the circumference, or on the section of the sphere. Project that down. I'm going to do the same with point B. I'm going to find a point on the circumference. Project it down. And now all I need to do is I need to take this radius and find the center point down here, and then the center point for point B will be directly across from it. So doing that, I'm going to get the radius. I can either use the elevation that we've been given and set the radius using my compass, like that. Double check it down here in plan. Dead on. So I'm going to now step down that far. I've now found the center point of sphere A in plan. So I can draw sphere A in plan using my compass. Like that. I don't have any sandpaper, so I can't sharpen my compass just now. So there we have sphere A. Let me see if I can heavy it in anyway a little bit at all. I can't really. So I have sphere A shown in plan. Sphere B will be in line or parallel to the XY line, so I just need to come across horizontally or parallel to my XY line. It's actually representing a vertical plane. And the same thing as what we've just did with A, we're going to do with B. We're going to take the radius and draw sphere B in plan. Oop. There we go. Made a little bit of a mistake there, let it slip. Just take care. So now we have shown both spheres in plan, and I've also shown the hidden detail, because we can see here that sphere B will sit slightly in under sphere A. So we've got that shown. Now we need to find the points of contact. So to find the points of contact, we need to find the point of contact in elevation where we can see a section through the 2 of these spheres. So let me pretend that we're going to cut these spheres in half. I'm going to use a green pen here. So along this green line we have created what's called a section plane, and when we look in we will see the largest diameter circle, or the extreme circle of these, or extreme section of these spheres. And it's here where we're going to see that point of contact. So the point of contact will be on the path which is shortest from both centres. So it's going to be on a line that joins A to B, both centres. And it will be directly where both of them meet. So we need to take that point, drop it down, and we'll find it just there on the same line that joins B to A. Now that we have the point of contact, I'm just going to label it here now. Point of contact. We drop it down. We find the center point on the line that joins both of them. We know that point of contact has to be on that line, so there's the point of contact in plan. That is part A done. We've clearly shown how we found the point of contact. So we joined both centres where the two circumferences meet. That would give us our point of contact. Now moving on to part B. Draw the projections of a third sphere of diameter 35 which is in mutual contact with both sphere A and sphere B and sits on the ground or on the horizontal plane. We need to show all points of contact. Now to do this we first need to find a sphere of 35 millimeters in diameter that's in contact with each A and B. So we need to do it separately. So I'm going to do the sphere for B, and then what we're going to do is I'm going to pause and I'm going to let you do the one for A as well. You can play the video back to figure out how to do it for A if you need to. So first off we need to find the height of the center point for sphere C. So the height of the center point, so we know that the diameter is 35, then the radius is going to have to be 17.5. So if I put a dot at 17.5 and I just draw a very light horizontal line parallel to my horizontal plane, I know that the center of my sphere has to be somewhere along that construction line. And if you think about it logically, the sphere has to be an extra 17.5 millimeters from this circumference out. So because this sphere is 35 millimeters in diameter, its radius will be 17.5, which means it will be at least 17.5 millimeters from the center of this sphere to the edge of this other sphere, which is shown here. So to do that, what we need to do is we need to add 17.5 to this existing radius. So I'm going to just extend this horizontal line, and I'm going to add on 17.5 millimeters, just like that, and I'm going to swing a radius very lightly with B as my center. Now I know that this here is 17.5, this here is 17.5, so this has to be my center point. To draw in the sphere, I would always draw a little projection line down so I can get the actual correct diameter, or radius, sorry. I'm going to put my center point, or my compass in the right center point, set my compass accurately, double check, and set perfectly. So now I'm just going to draw in my sphere lightly for now. There we go. So now I have my ghost sphere drawn. So this will be ghost sphere 1. Actually, I'm going to call it ghost sphere 2, just because I have a Solidworks model which might help. And I'm going to do the same here now with sphere A. I'm going to construct a ghost sphere, so you can do that. I'm just going to pause the video. Okay, now I have ghost sphere 1 constructed in elevation. I'm going to bring them down and find them in plan. So ghost sphere 1 up here, ghost sphere 2 over here. And because we can see the true circumference and position of these because they're touching side by side, they have to be in line with these existing ones here. So they have to be on this vertical plane here, this green line. I'm going to actually extend that to the left, and I'm going to drop down the center point for ghost sphere 1 and ghost sphere 2. We will construct them where they are for now. Before I do that, I'm actually going to find the points of contact too. So same as before, join the centers. So join A to ghost sphere 1. I find the point of contact here, and I can drop it down to here. I can do the same with B and ghost sphere 2. And I can drop that down just here. Ooh. It's just inside that circumference. And now I can construct both ghost spheres. So I set the radius to 17.5 millimeters. Construct both ghost spheres. And over here as well. Like so. But yet we're not finished because we need to have a common sphere. So this is a 35 millimeter sphere that's sitting on the ground touching sphere B. This is the same, but it's touching sphere A. We need to find one that touches both at the same time. Now, we know that the distance from sphere B to the center of this sphere needs to be this distance, and when we look down, it appears as this distance. So that distance cannot change. It has to be that far from here to here. So what I'm going to do is I'm going to swing an arc using the center point of sphere B in plan. I'm going to take the center point of ghost sphere 2, and I'm just going to swing an arc all the way around to touch sphere A. This is a construction line for now. I'm going to do the same from sphere A with ghost sphere 1. So this distance has to be correct in terms of where this other sphere has to be, because it has to be that distance away to sit on the ground and to touch sphere A. So I'm going to rotate this sphere down, and where they intersect, that gives me the common point where a sphere of radius 17.5 or diameter 35 that's sitting on the ground will touch both sphere A and sphere B. So I just need to now set the radius again to 17.5. Construct my sphere. Now bearing in mind it will be below both spheres, so it will be hidden detail once you pass the circumference. So hidden detail here, solid, hidden detail barely there, and continue on. And there we go. There is sphere C. This is sphere B and sphere A. Now, to explain this, I've created a quick Solidworks model. So I'm just going to jump over to that there now. Oh, actually, I need to show the points of contact. So I found a point of contact between this sphere and this sphere. So I need to rotate them around as well. So I'm going to take that point of contact, swing it around. I'm going to take the point of contact from B and ghost sphere 2. Swing that around. Join the centers and indicate my point of contact. POC, always indicate your points of contact. Same here. POC. And now we need to bring everything back up and construct our sphere C up here really quickly. So we know it's going to be directly above this point because it cannot move left or right. So it's going to be right in line with that green line that I just drew. Grand. Point of contact will be up here somewhere as well. This point of contact will be up here somewhere. And if I draw my sphere, so I need to just set my radius again. I know it's going to be up 17.5, so it's going to be right there. Draw my sphere. And have one point of contact already found. I now just need to find my other two. So join back the centers. I found one just here, POC, and one just here. And there we go, all done. So what that looks like now in 3D, so I'll let you just pause it there if you need to for a second. If we jump into Solidworks, we have sphere A and sphere B. They are both touching each other and they're sitting on the horizontal plane here. Now, when I look in from the front, we're going to see them as both circles. So if I just turn it off here, we're just going to see two circles. Now, when we want to see their point of contact, it will be on the point of, it'll be basically in the very center where we see the largest diameter of that sphere. So the largest point of this sphere here is a radius 37.5, so it's actually a diameter 75 sphere. So the only place we're going to see a 30 or 75 diameter circle is directly in the midpoint or the mid plane of that object. So if I just make this again 3D, so in order to find that largest circle, we would need to have a look at, not there, here, directly in the center. So we would have to have it. So that's where we will see that. Now, when we construct this ghost sphere, we will have to first find a sphere here that is in contact with this red sphere A. So we would create one sitting on the ground that touches that sphere, like that. So if we looked in from the side, we would see it there. Looking from the top, we would see a sphere, and it kind of sits slightly in underneath, as you can see just here. Then we will throw in the one touching sphere B here, and then we can rotate, or imagine that we roll them around. So if I show you the projections, they would roll around here, so their distance wouldn't change. They would roll until they come in contact with either sphere. So this one is already touching this sphere, so we're going to roll it around until it touches here. But there's no way we can know that unless we know how far it comes. So we have to draw this sphere and project this around as well. And then we have sphere C shown in 3D. Finally, it looks like that. Hopefully that makes any sense. If you have any questions, let me know. Thanks.